Okay, this is homework for part D. First, we need to write an Excel VBA function for calculating the Darcy friction factor using the Churchill equation, valid for both laminar and turbulent flow regimes. With this, calculate the pressure drop across a 100 meter long, 0.2 meter diameter pipe with a relative pipe roughness of 0.0001. When water flows through it at 0.1 meters per second cubed. Assuming electricity costs 15 cents per kilowatt hour, how much would it cost to operate a 100% efficient pump to maintain this flow for 2 hours? So I already created the Excel here, and the first step is to import the code for the Darcy function. We got this in class, so I'm just going to copy it in here. So that's all you need to do with that. Just close that. So row, that's going to be the third. Here. Length is going to be 100 meters long. 100. Our diameter is 0.2 meters. Our Q is 0.1. V, so for this one we need to do an equation. But first I'm gonna name all of these terms. Let's see, name manager. Create from selection, left column. Okay, so now we can reference these numbers just by calling up the name. So V, that is going to be Q dot over pi times D dot squared divided by 4. So that gives that 0.00318. Our Reynolds number, that's going to be rho VD. D all over mu. So that's, oh, not that. Okay, this is just going to be point 0.0001. Okay, so those are those terms. Now we can move on to the delta P. We can use all these to find delta P. I want to go ahead and add our units here. So we have AG meters cubed using Pascals, length meters, Q meters cubed per second. Okay, so now we can move on to the Darcy equation. Okay, so I didn't notice a mistake. I'm made here. I forgot to add parentheses, so that'll change our velocity a little bit, and also our Reynolds number. So this is our fixed number. So now I can move on to the Darcy equation. So equals Darcy F. That's going to be Reynolds number, comma, ED. That's our friction force. So then we multiply that by L over D. We multiply that by rho. And then we multiply that by velocity squared over 2. I think that parentheses here. So I think that is our delta P here, our change in pressure. So now we can move on to our power. And I'm going to name this real quick. So power is going to be equal to delta P times Q. It's going to be watts. So now we need our duration. Our duration is 2 hours, and we're going to convert that to seconds, and that would just be 7,200 seconds. Name these. This is just duration. I don't know if it's gonna change it. Okay. So now we need our energy. That is equal to our power times duration. So power times duration. So that's our total energy in joules. We get the energy in joules. We want that to convert that into kilowatt hours. So what we're gonna do is we're gonna take that number and divide it by 3.6. That's 2. 3.6 E6, and that will convert it from joules to kilowatt hours. So that is our number. And we want on the total cost, so that'll be the total cost. So it's 15 cents per kilowatt hour. So we do 15 cents times that are the amount of kilowatt hours we have. So cost, and this is equal to this number times 0.15, and that is the total cost we have for running this pump or whatever for 2 hours.